Welcome. If you're a senior architect, you already know the cloud compute landscape can be, well, a lot. So, in this explainer, we're going to map out Azure's core compute options and build a really clear, practical framework you can use for pretty much any workload you'll ever face.
So here's how we're going to tackle this. First, we'll talk about the core trade-off that's at the heart of every single one of these decisions. Then we'll take a journey right across the spectrum, starting with virtual machines and going all the way to serverless functions. And to finish up, we'll put it all together in a super practical decision guide. Ready? Let's go. You know, when you get right down to it, every cloud architecture decision really comes down to one fundamental choice. And it's not really about which service has the most bells and whistles. It's about figuring out where you need to be on this spectrum between control and simplicity.
And that choice really just boils down to this one question. For this specific workload, do you need absolute granular control over every part of the infrastructure? Or do you need to prioritize speed and just get stuff done with less operational headache? This is the central tension, the key trade-off every architect has to wrestle with.
Think of it like this. On one end, you have infrastructure as a service, or IaaS. That's where you get maximum control. On the complete other end, you've got platform as a service and serverless, which are all about simplicity. As you move from left to right, what you're really doing is strategically handing off responsibility to Azure in exchange for moving faster. So let's kick things off at the far left end of that spectrum with the absolute foundation of cloud infrastructure, the virtual machine. This is where you get total, uncompromised control. An Azure VM is exactly what it sounds like. It's your own dedicated server just living in an Azure data center. It is pure IaaS. You pick the operating system, you install all the software, you handle the patching, you configure the networking, you are 100% in the driver's seat. So when do you actually use these? Well, the use cases are really specific. If you're moving an old legacy application that you just can't change, that classic lift and shift, or if you have a workload that absolutely requires a specific OS configuration, VMs are your go-to. But the trade-off is huge. Yeah, you get all that control, but you also inherit all of the responsibility that comes with it. Okay, but what if you want something a bit more efficient and portable than just one big VM? Well, that question naturally leads us into the world of containers and orchestration. And in Azure, that means talking about Kubernetes. AKS is basically Azure's managed Kubernetes service. Now we're taking a big step up in abstraction. You're not managing individual servers anymore. Instead, you just give AKS your containerized applications, and it handles the really complex job of deploying, scaling, and managing them across a whole cluster of VMs for you. This makes the decision pretty clear, right? If you're building modern apps based on microservices that need to scale like crazy, AKS is unbelievably powerful. The catch? The trade-off is that your team has to be ready to dive deep into the Kubernetes ecosystem. And let's be honest, that comes with a pretty steep learning curve. All right, let's keep moving down the line. What if you want to manage even less? What if the real goal is to just focus on your application's code and not think about containers or clusters at all? This is the whole promise of Platform as a Service, or PaaS. And Azure App Service is the poster child for PaaS. It's this fully managed platform where you literally just bring your code, whether it's .NET, Java, Node.js, Python, whatever, and Azure handles everything else. The web servers, the OS patches, the load balancing, the scaling, it's all taken care of. And this right here is the core value. For most of your standard web apps and APIs, App Service is hands down the fastest way to get from code to production. Your teams can just ship features instead of worrying about servers. The trade-off is simple. You give up that fine-grained control over the environment in exchange for pure speed. And now we've arrived at the far right end of the spectrum. This is the place where the whole idea of a server pretty much just vanishes from your mind. Welcome to the serverless frontier with Azure Functions. With Azure Functions, you're not even deploying a whole application anymore. You're deploying these tiny, independent pieces of code. And they don't run 24/7. They only execute when something happens, a trigger, like a new file getting uploaded, a message popping into a queue, or a simple web request. You literally manage nothing but your code. So this model is absolutely perfect for specific event-driven jobs. Think about creating an image thumbnail right after it's uploaded, or running a nightly cleanup script. This is peak operational simplicity. The trade-off is that it's a specialized tool, kind of like a scalpel, not a Swiss Army knife. You wouldn't run your whole company website on it, but for the right job, it's unbeatable on cost and efficiency. Okay, so we've traveled across the entire spectrum, from having total control with VMs all the way to total simplicity with functions. Now, let's pull all of that together into a simple, actionable guide you can whip out at your next architecture review. Just think of this table as your go-to cheat sheet. Got a legacy app? Start with Azure VMs because you need that control. Building with microservices? Look right at AKS for its orchestration power. A standard web app or API? App Service will get you to market the fastest. An automated event-driven task? Azure Functions is going to give you maximum efficiency. It really does all come down to matching your workload to the right spot on that spectrum. And that brings us to one last thought. We've seen this really clear trend, right? The more control we hand over to the platform, the more speed and simplicity we get back. But as this abstraction keeps getting deeper and deeper, what does the next frontier of cloud compute even look like? And what new, maybe even unforeseen trade-offs are we as architects going to have to navigate next?